Hello everyone, in this video we are upgrading this 12 volt 400 amp hour emergency power kit that I have been building for the last few months. We're doing one final upgrade. We are upgrading the way I have been doing the pre-charging of the capacitors of the inverter with this 12 volt voltage tester. We're replacing this with that. A hobby box that will have a DC cutoff switch, a red LED indicator, a momentary on push button, and however many of these will be necessary to create a pre-charge kit, a pre-charge circuit, a pre-charge box between this 2000 watt pure sine wave inverter from Jupiter and my 12 volt 400 amp hour batteries from WattCycle. Here we go. So this probe worked out really well in pre-charging the inverter capacitors, so I'm not toasting my inverter. This 2000 watt pure sine wave inverter from Jupiter doesn't have a pre-charge circuit, so I have to make one. And I've been using this for a while now. It's worked well. However, I want something that's a little bit more permanent for my family so they can utilize this inverter kit, this emergency power kit, and then from there they can just turn on the inverter and hook up everything to get power back into the house in case of a power outage. And as you can see, I already have a couple of holes started. One hole is going to be for the push button. One hole is going to be for the light. I need to drill a nice big hole up here for this DC cutoff switch. And that is what we are going to do right now. Hose cut. Let's clean it up. So with this hobby box, originally I was going to use the grommets that came with the box to secure the 2-aught cables onto the box. But the problem is these grommets, that's what I'm calling them anyway, grommets, are slightly too big to allow this 2-aught cable to go inside of them. And I am not a fan of cutting my cable to install lugs, which is actually a good thing because I'm going to need the ability to move this box, because when I utilize this switch cover, everything's going to be mounted on the lid itself, which is awesome, except how am I going to get to the bottom of the switch to tighten down the nuts? So, and those cables do not bend very well because of the simple fact that they are as thick as they are. I'm going to have the ability to slide this box up and down the cable length in order to bring this up in order to access the terminals on the bottom of the DC switch. The rest of the circuitry, the light and the push button and however many pre-charge resistors I need, all that will be easily accessible on the bottom of this lid. Slight revision to what I originally had planned, but at least this way I will be able to utilize the box. Thought process of doing this is my family or I, if we need to pre-charge that inverter before we turn on the main battery or turn on the DC circuit, the full circuit, anyone can come down to the inverter, press this button, allow this light to extinguish, and then turn on that switch to power up the inverter. That is the goal of the pre-charge circuit, because using that probe, even though it did its job and it did it well, I'm looking for something that's a little bit more user-friendly for my family. So first thing first is I need to figure out what the ohms are involved with this old 12 volt DC probe to get an idea how much resistance I need to install using these pre-charge resistors. This is a incandescent light, whereas the light I'm installing is an LED. So I suspect I'm going to have more of these resistors in order for me to equivalent the resistance that's inside this light. But we need to check for resistance, or check for the ohms on this probe to see where we're at, if I can get the reading off of this guy with using this tester. We're using this multimeter here. Looks like 122 ohms. 122 ohms. Once it stabilizes. All right, 140 ohms. So, yeah, we'll call it 140 ohms. With the light being an LED, I don't think there's going to be much resistance within it. Let's double check. So the light itself is yeah. The light itself isn't even resistor resistance, so, but again, that's an LED for you. There's usually not a whole lot of resistance in LEDs anyway. And usually not a whole lot of resistance in LEDs anyway. Just like that. I don't have a schematic, but basically you're going to have our 2-aught cables come onto both sides of this DC cutoff switch, and then I'm going to have a small gauge wire coming off of this side of the switch going onto this side of the light, and then the circuit comes over here, goes through this pre-charge resistor, goes through the push button, and then I have another small gauge wire coming off of this side of the push button back over to this side of the DC cutoff switch. So this will do for now, but in the meantime, I'm going to go ahead and hook this up to between the batteries and the inverter, and we're going to see how it functions exactly like it is right here with the LED light, the 390 ohm resistor, which is rated for 10 watts, and the push button switch. So we're going to see if I can smoke either that light or that resistor here in just a second. All right, back at the emergency power kits on a cart. We are going to see how successful I am in letting this work just as it is wired up currently. I have an outer gear clip coming off the bus down here. That's going to this clip right here, and then I got another clip coming off of the inverter, and I got that clip coming over here to this guy right here. So should only need to hook up this side of the push button like so, and then hook up this side, this clip, over to this side of the light. No spark, that's good. So the circuit is fully in place. Now let's see if I smoke the light, the resistor, the wire, or both. 3, 2, 1.